We talked in the last lesson about radiation, conduction, and convection, and how this energy transfer results in air moving around. So that's what wind is. It's just the movement of air. We have areas on our planet that have higher pressure than others, and we talked about atmospheric pressure and how much that air is pressing down on the surface. When we have areas of high pressure, it means that the air is being squished down towards the surface. It's descending or going down, and it's squishing down, and it's going to shove the air that's already there out of the way. So it's going to move from that area of high pressure to that area of low pressure. And we have the low pressure areas are at the equator because that's where low pressure means the air is rising. There's not very much pressure because the molecules are spreading further apart, and they do that as they rise. The cold air sinks at the poles where the temperatures are colder, and so that's where we get the areas of high pressure where the air is getting squeezed down towards the surface, and it just circulates back and forth between those areas of high and low pressure. So because of the way our planet spins, we get these cells. They're called convection cells, and they're found every 30 degrees latitude. And so we're going to talk a little bit about each one of those. So our polar easterlies, this wind belt happens up towards our poles where the cold air is descending and it's pushing it down towards the center of the planet. And so this is why we get cold weather in the wintertime. We get it for two reasons. One, because of our tilt of our planet. We're tilted a little bit further away from the sun. But also because in the wintertime, we tend to get this cold air coming down from the Arctic, from the polar easterlies, that kind of catches onto the jet stream that we'll talk about in a little bit, and it pushes it down towards Arizona. We live in the Westerlies. The Westerlies are between 30 and 60 degrees latitude. Remember, latitude is the flat horizontal lines that are on the globe. And so between 30 and 60 degrees latitude is where we live. The air goes from the west toward the east, which is why we get storms that come from California and from the Pacific, and why we don't get storms that come from the east coast to the west coast. The storms go from the west to the east, but they never come backwards. And they bring moist air from the Pacific Ocean over towards the United States, and that's where we get our rain and snow. So we get some that come from the North Pacific. That is what catches some of that cold air that comes down from the polar easterlies and pulls it into the westerlies. But when it comes straight across, or it comes from a little bit south and up, they call it the Pineapple Express. And this is the warm storms that we get that come out from over near Hawaii. The trade winds go almost down to the equator, and they go up to 30 degrees north latitude. They call them the trade winds because that's how Europeans got to the Americas. So they would come down from Europe, and they would come down the coast a little ways until they got into the trade winds, and that would blow them across. And that's why Columbus, when he got here, he actually came down to like Cuba and down into Florida. He didn't come initially up to the northern part. To get to the northeastern part of the United States, they either had to come down through the trade winds and hit the southeastern part of the United States and then go up the coast, or they had to go all the way up into the polar easterlies, and they had to go across over the top of the Atlantic in the North Atlantic where it was really cold, kind of like they did when they came from Greenland and the Vikings came over here. So, but that's why they're called the trade winds, because that's how they got back here. And then they could use the westerlies to get back. So they could make a much more straight shot. So it took less time to get from the Americas back over to Europe than it did to get from Europe to the Americas back in the day of the sailing ship. Our jet streams don't really follow that pattern. The jet streams are kind of like these currents or rivers of air that move through, and they kind of shift around. They shift around based on areas of high and low pressure, the storm systems that are moving around. And so they move really fast, and that's why sometimes if you're flying from the west coast towards the east coast, you can catch a ride on the jet stream, and it shortens up your flight. So they say if the jet stream's pushing us along and helping us out, it's because the airplane actually got into the jet stream, and now you're going at 200, 300, 400 kilometers. You're going a lot faster than what the plane can do all on its own. That's why they try to avoid the jet stream when they're coming back from the east coast, because otherwise it'd be like you're pushing up against the wall as you're coming back. But because we know how the jet stream usually acts, it's why they can predict weather. And so when they look out and they see, oh, well, the area of high pressure is moving out, and it's going to allow the jet stream to dip back down, that's how they can predict storms, usually here in Arizona. So those are global winds. The doldrums exist right near the equator. The doldrums are an area where there's not very much wind. Most of the air is just rising up, so there's not a whole lot of wind action going on. And those explorers, as they were coming through and they were passing through the equator, they had to really avoid the doldrums because they could get stuck there for a long time if they didn't have oars. They couldn't move their ship through. They really tried to avoid going parallel to the equator because they could get stuck there for a really long time. So we have our easterlies, we have our westerlies, we have our trade winds, and those are our big global winds. We also have local winds, and the local winds are based on the topography or how the lay of the land is in that particular region. And so our first one that we're going to look at is a sea breeze. The sea breeze happens because it's daytime, so we're going to do some drawing in here. So it's daytime, the sun has come up, and there's something that we need to know about the property of land and water. And the big thing about land is that it heats up and cools down more quickly than water does. So when it's daytime and the radiation from the sun is coming down and it's heating the land, it's going to heat it up faster than it does the water. And so the warm air is going to rise from the land up into the air. And remember we said that where it's colder, the air is descending. The air is descending, so it's still descending over the top of the ocean. And therefore, since the air is descending here, remember, it's squishing all those air particles out and it's trying to shove them out of the way. And so that means our air moves from the area of high pressure to the area of low pressure. So this is high pressure here, over the water, low pressure over the land. And so if you go to, during the day, if you're at the beach, this is why the wind, if you're standing at the water's edge, the wind is hitting you in the face. Because during the daytime, it's going to move towards the land. A land breeze is the opposite. So now the sun has gone down, and now the moon is out. Excuse my poor attempt at a moon. But the land, remember, heats up and cools down faster, which means the water retains heat faster, which means it's now warmer over the ocean, which means the air is now rising over our ocean. And so this is now our area of low pressure. It's colder over the land, so the air is descending. This is our area of high pressure over the land. And as a result, remember, air wants to move from an area of high pressure where it's getting squished to an area of low pressure where it's not getting squished. And so the air is now moving out towards sea. And so at the nighttime, if you're standing once again facing the ocean, now the wind is going to be at your back. We have a similar kind of effect that happens with our mountain breezes. So up here on the top, at night, we're going to start out with nighttime. And up this high, it gets cold here a lot faster. Up here at the top, it's exposed and it loses heat faster. So the air is going to move down the mountain until you get down to the flat areas. Especially if there's valleys in here, the warmer air is down at the bottom and it's going to rise. So once again, here's my area of high pressure, and here's my area of low pressure. During the daytime, this is going to flip. So this is at night. During the daytime, it'll be reversed. So now when the sun is up, the sun hits the top of the mountain first, and so it warms it up at the top, which means it's going to, the air is going to rise here, and the air is descending here, and it's going to get pushed up the side of the mountain. It's going to act kind of like a chimney. It's going to draw that air up, and the air is moving up. So this is my area of high pressure, and this is my area of low pressure. So it just depends on if it's the daytime or the nighttime.